In this video, we'll look at question 11 from the second paper of the 2017 exam. In this question, we have two functions, f and g. We know two things about f. One is that at 0, it takes the value 0, so it goes through the origin, and then it's always increasing. And now assuming a and b are positive numbers, where a is smaller than b, the region under the curve of f of x is now called R. That means the integral of f of x from a to b, something we could write like this using an integral. And using this function f of x, we define a new function g of x, which is just f plus twice the value of f at the point b, which is just a constant. F of b will be just a number, say 8, right? So we are just adding 16, I just made up 16, but like a number, which is positive, because of all this business with f starting at 0 and then being increasing while b is positive, so it has to be a positive number, which we are just adding to f of x for all x to create our g of x, which is now in red. And our task is to find the area under this red curve from a to b in terms of r and other variables which we are given. Well, one thing we know for sure, that this new area is going to be r plus this remaining area, which I'm going to shade in green, and let's call it s, right? That will be our s. Now, can we find an expression for s? Let's look at it a bit closer. So imagine it looks something like this, with f of x in blue and g in red. Now, what will the height of this shape be, and will it be constant? It must always be constant, because remember, g of x is defined just as whatever is on the blue line plus always the same constant. So the difference in heights here, this length will now be 2f of b. And that is the same throughout, here and everywhere along the x direction. The length of the region over which we are integrating or calculating the area must be b minus a, because we are going from a to b. Those are our limits of integration, or simply the x values on these sides. And now let's split this area up into little stripes. So remember, all of these are of the same height, and their width combined gives b minus a. So what happens if we now rearrange them a bit? If we put them just in a row, one after each other, like this, they will now form a rectangle of one side b minus a, and the other side will be 2fb. And the area stayed the same. We just rearranged these little rectangles. We didn't change the area of anything. And so it must be that s, which is the area of this rectangle, is 2b minus a f of b. And hence the area which we're supposed to find under the red curve is r plus s, which as we now know is 2b minus a f of b. And that is the area which we were supposed to find, and in the exam it was under option B.